So good morning, everyone. Today what we're talking about solving, again, quadratics. And a quadratic is the idea of ax squared plus bx plus c equals to 0. And this is our pretty much standard form for it. We make it equal to 0 because it makes it easy for us to solve. We had a couple ways of solving problems like this. A is just a number in front of x squared, b is in front of x, and c is by itself. They're really just placeholders. So, sorry, someone just came in. Really just placeholders. So let's talk about what we have been able to do so far. So if I give you a problem that says x squared plus, let's do 7x plus 10 equals to 0. And I ask, let's go ahead and solve for x. We've actually had a couple ways of solving this problem. One way is to just simply factor. I consider the easiest way to solve a quadratic, if possible, is to factor. And I asked you guys to break this up by just writing little notes to yourself. We know it's going to become something times something. So the front, of course, is easy, xx, because x times x is x squared. The back, we have possibilities of 1, 10, and 2 and 5. 1 times 10 is 10, 2 times 5 is 5. And I asked you guys to write this out, and this is the way I teach factoring. Some of you guys are very visual people, so if you can see the possibilities, it clicks a lot faster. So does 1 plus 10 become 7? Nope. Does 2 plus 5? A plus sign says we're going to add because they're both going to be positive. Plus 2 plus 5, yeah, that's 7. So we know our numbers can be 2 and 7. So we have something now called the zero product property. And that's a nice little trick. It really is a trick more than a property in my mind. It says if I'm making something multiplied to become 0, either of those could be 0. This could be 0 or this could be 0. So how can I make x plus 2 equal 0? Well, if x was negative 2, right, wouldn't that make it 0? And 0 times anything is 0. What about if the right side was 0? X plus 5 is equal to 0. X is negative 5. So we have two possibilities here. Great. And if I tried it, double checked, if I plug in negative 2 to the original equation, 7 times negative 2 plus 10, this doesn't look like 0, or does it? 4 minus 14 plus 10. Oh, that was 0. Oh, that's lucky, right? Well, let's try negative 5. Negative 5 for sure doesn't look like it's going to work. But, oh man of little faith, this is 25 minus 35 plus 10. Oh, that's also 0. Amazing. So factoring is one of our easiest ways, again, I would say, to solve for a problem if it's x squared. Okay? We had other ways. Another way was completing the square. Now, this is not, I mean, if I see a problem like this, x squared plus 7x plus 10, I'm not thinking completing the square right away. But it is in my toolbox. So let's go ahead and let's complete the square for this problem. X squared plus 7x plus 10, and we're going to complete the square. So to complete the square, we bubble up first, writing our perfect square. So unfortunately, this is a level 2 because this is odd. And if it's odd, you can't divide it by 2. But know what? That doesn't matter. We're going to still push on through. X plus 7 over 2. Please don't be afraid of writing it as a fraction. On the test, it will tell you which method to use. If it doesn't tell you, you can choose whichever method you want. So if the test says use completing the square, you have to complete the square. If it says factor, you have to factor. And you'll see that on the practice test. Squared. So that is my perfect square. What's the c I need to make this true? We square 7 over 2. We square 7 over 2. Because for sure that's not 10. So we write plus 49. Let me change the ink here. We say plus 49 over 4. And to balance out the equation, we minus 49 over 4. And if you saw my previous video or you were in my previous class, you see I do these problems always like this. Same pattern every single time. we always divide by 2, then square it, add it, and subtract it because we're balancing out the equation, and we're going to flush out the rest, combine the rest together. Now, negative 49 and 4 don't seem like a great number to mix with 10, so we change the 10 by multiplying that by 4, so we get a common denominator. I'm going to change this color a little bit. So this becomes plus 40 over 4. Isn't 40 over 4 the same as 10? Right. So I'm just writing it over. The difference between level 1 and level 2, level 1, this is even, so it's super easy to divide. Level 2 is when it's odd, so then it gives you a fraction of 2. That's the only difference. Level 2 is harder because of the fraction, and we have to take this extra step to get a common denominator. Now we have here our negative 49 plus 40, which gives us negative 9 over 4. You guys agree with that? Right, if you guys have a different method of learning how to complete the square, there are several methods out there. I just find mine easiest for my brain. If you have another one that's better, send me a picture of it beforehand, just so I know that you're not using a cheat on the test. Okay. Equals to 0. Now, we said we can do all this in one step. So we're solving for x. We're going to get rid of the 9 over 4, the square, and the 7 over 2, right? I'm getting rid of everything, so x is alone. And we can do that all in one step. So I'm going to add 9 over 4. I'm going to take the square root. Then I'm going to subtract 7 over 2. Add 9 over 4. Take the square root plus and minus. And then we're going to minus 7 over 2. And that's what x equals to. How do I get 40 over 4? I need to somehow combine the leftovers, which is negative 49 and 10. Negative 49 over 4 and 10. But 10 isn't a fraction, so we change it to a fraction. So common denominator. The denominator I need is a 4. So 10 times 4 is 40 over 4. I made change. Now this last step, we're going to go ahead and do one more step to it, is let's go ahead and take the square root of 9 and 4, negative 7 over 2 plus 3 over 2. No plus and minus. We have two versions. Negative 7 plus 3 over 2 and negative 7 minus 3 over 2. So we end up with negative 4 over 2 and negative 10 over 2, which simplify out to become negative 2 and negative 5. Just can we do x plus 7 over 2? Yes, and then you don't forget. Okay, so if you look at the chat, Danya asked, can I write x plus 7 over 2 equals to 3 over 2? Yes, but don't forget it's a plus and minus 3 over 2. Right? Because of the square root. So don't forget the plus and minus. And then also, eventually you're going to move it over anyways. Yeah, you don't have to move over the 7 over 2 immediately like I do. I just try to write it as one step because kids always complain about it's too many steps. And then just don't forget, again, the plus and minus. Because when you take a square root, when you actively take that square root, you have to write a plus and minus in front of it. I do not want the decimals, actually, because you don't need calculators on this test. So I don't want the decimals. I prefer the fractions are fine. Okay. And we see that these answers are the same. Right? Negative 2, negative 5 over here. So which one do you prefer? I'm pretty sure everyone's going to say factoring. And I 100% agree with you, right? But I would also say that if you complete the square, we get one extra bonus point, and that's our vertex. If you remember this form here, let me clean this up a little bit now that we're done with it. If you remember, this form here is actually our vertex form. And the vertex of the parabola is negative 7 over 2, comma, negative 9 over 4. Remember, it's going to be a negative. Let's write it out. Ax minus h squared plus k, right? Where h is x minus h, so whatever that value, we're going to give ourselves a negative version of it. So if you are trying to graph this parabola, hey, the vertex is very nice to have. The vertex is super nice to have, right? So factoring is great. It gives me my zeros. Completing the square is nice because it gives me a little bonus point, my vertex, and the answers. This is so much easier if this was level 1, okay? FYI, this would be super easy if this was level 1. Yeah, just go ahead and send me a picture through email, okay, so I can search it up. All right, and then now we have one more way, and let's talk about today's method. This is quadratic formula. The quadratic formula is a pretty much, think of it as a microwave meal. It's all done for you. Just toss in the microwave, kick in 3 minutes, and it's done in 3 minutes, right? There's no real thinking about it. Let's see, sorry, I need to read a question. When the denominators are the same, do we put them all over the same denominator? Yeah, so if I write something, so someone is asking about the denominators. If I write 3 over 2 plus minus, let's say square root of 5 over 2, if they have a common denominator, yeah, you could write them as over one denominator. You don't have to, it doesn't hurt. But on a multiple choice test, you oftentimes see it written together. Okay, back to the quadratic formula. So the quadratic formula for us, I also call it the hammer. There's no real thinking when you're doing quadratic formula. It's just plug and chug because it's already done. It's, again, like a TV dinner, a microwave dinner. Right? It's even easier than going to McDonald's. You have to drive to get to McDonald's. I guess with Uber Eats these days, you don't really have to. But here's our formula. X equals to negative b plus and minus square root of b squared minus 4ac all over 2a. I hate that song. But some kids like it. Some of your algebra teachers have taught you to sing that over and over and over. And some people, like that melody. I would just say, memorize it. Right. Now, where do the a, b's, and c's come from? Just like for all our quadratics, we have ax squared plus bx plus, darn it, not plus c, equals, plus c, sorry, equals to 0. So a couple of takeaways. This must be equal to 0 because we're solving for 0. If it's not equal to 0, move everyone over so it is equal to 0. So our problem is, we said x squared plus 7x plus 10 equals to 0. We're going to label first my a, b's, and c's. A is 1, b is 7, and c equals to 10. That's one of the first things that you should do. Oftentimes kids mess up because they mislabel. They forgot to write the negative or positive values. So what we're going to do is now we're going to fill in all the a, b's, and c's. And we might sing the song for this again. X equals to negative b, which is now 7, plus the minus square root of b squared, which is now 7 again, minus 4ac. A is 1, c is 10, all over 2a, which is now 1. So please remember that a, b, and c is from our quadratic here. And a is in front, b, and c. Now, if you're missing any values, you plug in a 0. If it's invisible 1, write the invisible 1, and make sure you do catch any positive and negative signs. So x equals to negative 7 plus and minus the square root of 49 minus 40 all over 2. And negative 7 plus and minus square root of 49 minus 40 is 9 all over 2. And we can keep on going. The square root of 9 is 3. X equals to negative 7 plus and minus 3 over 2. Oh my gosh, there's so much writing. And we're left with negative 7 plus 3. So we have two versions now. negative 7 plus 3 over 2, and negative 7 minus 3 over 2. So negative 7 plus 3 on top is negative 4 over 2 is negative 2. And negative 7 minus 3 down here is going to be negative 10 over 2, which is negative 5. Not surprising, the same exact answers. Now there's no creativity in the quadratic formula, right? When factoring, you had to figure out which numbers work, which pair work. Let's go back and quickly review. Well, I'll just talk it in case some of you guys are still copying. When it was coming into factoring, you had to be creative of which numbers you would mix together to form that 7 in the middle. Was it 1, 10, or 2 and 5? If this was a level 3 problem, you would have anywhere from 4 choices to 50 choices. And you had to be very creative of which one would match and work. Complete the square is a little more work, I would say, right? But it gives you the vertex too. And the complete the square can be difficult in the level 2 or level 3 mode. That you practice level 2, you can actually get that out pretty quick. And quadratic formula just works. Now, I have a shortcut. Some of you guys are shortcut people. I'm a shortcut person. And here's my shortcut. All this writing here, this whole level here is actually redundant. We actually don't need it. If we look at the inside part right here, this is what we're going to call the determinant. The determinant is going to be this b squared minus 4ac part. That's what the determinant is. So we're going to steal that out. I'm going to show you guys a trick. And this is something that's going to be in ISL today. The determinant is a special trick, we could say. But the determinant helps us find is their solution to the quadratic. That's the overall idea of the determinant. It's going to tell us before we even commit to do all this work if this will be an imaginary point or a real point. Okay? The reason why is I can't take a square root of a negative. That's not going to work. And if you look at a parabola, if a parabola is floating in the sky, are there any points that would actually be 0? No. So when the quadratic is floating in the sky like this, that means we end up with no zeros. And our determinant will be negative. So let's go take a look at that determinant real quick. B squared minus 4ac for this problem was 7 squared minus 4 times 1 times 10. Because our a was 1, our b was 7, and our c was 10. So the determinant is really just the inside part of this quadratic. Now, how hard is me doing this? 49 minus 40 is 9. What's the square root of 9? 3. Just jump here. So as a side note, instead of writing all this out here, this whole step, if you just take a sidebar out, you say, oh, hey, 7 squared is 49, minus 4 times 10 is 40, that's 9. Well, 9 isn't imaginary. That means we do have 2 answers. What's the square root of 9? 3. Just jump from here to here. Because if you notice, in the red, all we're doing is copy, 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 which is kind of a waste of our time. So let's do another quick problem now. Same exact style. Let's write x squared plus, let's do 5x plus, let's not do plus, let's do minus 5. Now, this problem here, we're going to look at it right now. Is this factorable? It could be imaginary. That's a possibility. So looking at this problem here, is it factorable? Numbers that multiply to become x squared, well, that's just x and x, right? X and x. And numbers that multiply to become 5, 5 and 1. Does 5 minus 1 become 5? No. There are none. So this isn't factorable. So one thing about this is that when it's not factorable, darn it, we have to find another method. You can now choose completing the square or quadratic formula. And we're going to use quadratic formula because that's our example today. So x, a is equal to 1, b is equal to 5, c is equal to negative 5, automatic. And then we're going to start filling out quadratic formula. And you might say, man, that's a lot into the work. I'm going to tell you, we're going to be done by the time you stop complaining. X equals to negative b plus or minus square root of b squared minus 4ac all over 2a. You're welcome. I'll leave a hat and a tip jar on the floor. Can you use 5 over 2? Oh yeah, we could have done that. Yeah, for sure. We could have done quadratic formula. Okay. Oh, we can complete the square. 5 over 2 would have perfectly been okay. Now let me continue here. Now I'm going to jump off to the side. I'm going to take my determinant. Okay, that's going to be 25 plus 20. Look how much work that was. So instead of writing the whole thing over again, I'm just going to, on the side, just do the square root on the side. And 25 plus 20 is 45. And 45 is a legit possibility. Now, could you take the square root of 45? What is the square root of 45? The square root of 45 is 9 times 5. Well, the square root of 9 is 3. And the square root of 5, you can't do it. Now, here's the cool thing. If you take a side note and do the determinant on the side, you've done the square root. And we just have to go back and plug it in. Plus and minus 3 square root of 5 over 2. You might have blinked and you might have missed it. But if you look at here, it's almost a two-step problem with a little sidebar on the side. Now, can you combine this anymore? Unfortunately, no. This is not a nice, what we call a rational problem. This is irrational. The square root's going to lead us to a crazy decimal, and that's just what life is. Most problems in the world are decimal problems. We might not like it, but that's just what it is. So we can leave it like this. If you want, you can practice with a calculator and write it out on the calculator. Now, would we have received the same exact answer if we complete the square? I think on iExcel, you might be able to put 6.71, I think. It might ask you to round to nearest hundredths. Let me take a look here. And iExcel is actually asking you, oh, you can write your answer as an integer, improper fraction in simplest form, or decimal or rounded off fraction. Do we need to put into a negative or positive equation? Yes, because this is two answers, and usually they'll make you write it out. So plus 3 square root of 5 over 2, and negative 5 minus, sorry, I'm making it look like a cube root. Let me erase that. 3 square root of 5, and 3 square root of 5 all over 2. Yes, there are two versions of this. Go ahead and work on the test review, and they'll tell you which type of questions and what they want. It's all about, remember, every testing software is a little different. So read the directions and they'll tell you which version they want. So on your test, you can't tell me that you did this in your head. Some kids, oh, Mr. Joe, I did this in my head. Impossible, right? You can't do this in your head. So if I don't see the work, I think you're cheating. And I hope you're not cheating. Hopefully you've learned this. Hopefully you're learning this and you're doing this faster. Again, on the test, it just depends. Read the question on the software and it'll tell you which one they want. So be flexible in that way. Now, could I have done this in completing the square? Actually, yeah. It would have been a little ugly, but yeah. X squared plus 5x minus 5 is equal to 0. It turns out, you guys didn't know this already from Algebra 1, but completing the square is the backbone of the quadratic formula. Do you know how quadratic formula, we just have to memorize x equals negative b plus minus square root. You memorize it, The quadratic formula is created by completing the square. We'll be able to use a calculator if we want. If the answers are going to be decimals, you can use a scientific calculator. That is not a problem. I just don't want you guys using using your phones and then all of a sudden having magical answers, and then I have to argue with you. Okay. All right, here we go. This next step. Let's go ahead and complete the square. What do you do with the 5? We divide it by 2. Okay. Our perfect C is square it. So plus 25 over 4 minus 25 over 4. Not hard at all, right? And then we're going to multiply to get a common denominator of this 5. 5 can't talk to 25 over 4. So we multiply and we end up with a negative 20 over 4. Now, I want to show you something. Can you guys get close? Get close. See these numbers here? These are these numbers here. Oh my gosh. B squared minus 4ac. All right, let's go ahead and combine them. That's going to give us negative 45 over 4. Look familiar to you? Look familiar to you over here? And we're going to say equals 0. We have just completed the square in one step, or like, a couple steps, but it looks like one step. All right, and then we're going to go ahead and solve for 0. X equals to negative 5 over 2. We're going to say plus and minus the square root of 45 over 4. Now, if you guys zoom out a little bit, that's actually this answer here, right? Because what's the square root of 45? This is going to be negative 5 over 2 plus minus the square root of 45. We did it over here on the right side. We did that. 3 square root of 5. And what's the square root of 4? 2. We do have a common denominator. We can rewrite it as negative 5 plus and minus 3 square root of 5 all over a magical 2, which is our answer here. Now, I think the quadratic formula for hard problems is easier. Just memorize it, fill it in, and take 2 steps, and you're done. Completing the square, you could mess up along the way, right? You can mess up along the way, moving stuff around. So quadratic formula really is, I call it the hammer. It fixes anything, right? The hammer will solve it. If you're stuck, you're confused, just take out the hammer. Take out quadratic formula. But we learned completing the square because completing the square is the backbone of the quadratic formula. The way we prove the quadratic formula is actually with completing the square. And if we were in class and we had more time, I would definitely show this out. If you guys want to see the proof, you guys can always write on YouTube, proof of quadratic formula. You can find thousands of videos of people doing this exact same problem, getting from A, B, C to the quadratic formula using completing the square as their tool. Okay, so one of the things for Excel, you guys are going to work on this discriminant. And the big deal about the discriminant, it tells you if there are 1, 2, or 3 solutions. Let me express this. So let's say our problem is x squared minus 4. Let's do minus 4x plus 4. Okay. Now we're going to use a discriminant. And then we're going to notice something interesting about this. The discriminant is b squared minus 4ac. So our a, b, and c, right? Just taking each of those coefficients, also with a sign. So b squared minus 4ac. The truth turns out to be 16 minus 16 is 0. So what does this mean for the problem? If this discriminant is 0, it means, this is the takeaway, only one solution. one specific real solution. Why is that? Well, let's look at the quadratic formula. X equals to negative b, which is negative 4, plus and minus square root of b squared minus 4ac all over 2a. So I wrote that and I left it as a b, a, and c version, okay? What happens to this whole problem if the discriminant is 0? Do we even have to write it? The whole reason why we even have two solutions for quadratics is because of this stupid plus and minus here. This plus and minus messes us up and gives us two versions. But what if those two versions was 0 and 0? We don't even have to write it anymore. So what happens is this becomes 4 over 2, which is 2. So one thing we want to realize for discriminant is that if it's 0, that leads us to only one solution because you don't plus and minus anything. You don't plus and minus anything. If the determinant is positive, no matter what the positive number, we always end up with two possibilities. Right? Two possibilities. And if it's negative, so I'll create a chart for you guys in a little bit, but just to prove this to you real quick, to prove that to you, this is really x minus 2 and x minus 2. Negative 2 times negative 2 is positive 4, and negative 2 minus negative 2 is negative 4x in the middle. And the answer to this guy is 2 and 2. It's the same 2. So a couple of rules. Let's go through the discriminant rules. So discriminant rules. If the discriminant, let's just call this a big D, is equal to 0, we have one real solution. Okay, so if b squared minus 4ac, which is our D here, if that is 0, we have one real solution. If D is equal to some number, any positive number, okay, any positive number, that means that's going to lead us to two real solutions. And the last one, if D is negative, we have no real solutions. We actually have two complex ones. That means these have I in it. Why do they have I? It's because the graph is never touching 0. This graph here, the graph is touching 0 at two places. And this graph here, the graph is touching exactly, landing perfectly on the moon at one spot. Okay, so the determinant, I don't find it very useful, but some people like it, and they oftentimes will ask it on the SAT or something. And I just want to make sure you guys have been exposed to it. The big problem with quadratic formula is that that's square root. If I take a square root of a negative, we're screwed. The answer is not real. And the reason why it's not real is because the zeros are not real. There are no zeros. So if you take the square root and it's negative here, right? X equals to negative 3 plus and minus square root of negative 5, that's say, over 2. See how that's negative? Oh no, it means there are no real answers. That means the graph was actually floating in space. Okay, if the square root, negative 3 plus and minus, let's say square root of 5 over 2, hey, that's positive. That means we have two possibilities. We have a plus square root of 5 and a negative square root of 5. So we have two real answers. They might be ugly and they might be beautiful, but we have two. And what if it's 0? if it's not positive and if it's not negative, it might be 0, right? Numbers can either be positive or negative or 0. So if it's 0, we only have one solution. And that's kind of the quick cheat sheet for determinants. So without even doing quadratic formula, we can tell if are we going to have 1, 2, or 3, and 1, 2, or 0 answers. Okay, the last step here is talking about going back to the graphs of parabolas. And I just want to give you guys one last thing about graphing parabolas. And there's some cheap tricks. These are some cheap tricks. A cheap punch. Cheap tricks. First, if it's x squared with a positive a value, okay? Blah, blah, blah. It means it could be whatever you want. I don't really care about the back. Honestly, I don't. We're going to be able to tell the graph of the parabola just by looking at this front key right here. If a is greater than 0, if a is positive, you can guarantee your graph is facing up already. It could be here. It could be here. Oh, that looks ugly. Or it could be here. It could be to the right. It could be left. I don't care. I just automatically, I know it's going to be facing up. If it's negative, if a is less than 0, negative, you automatically know it's facing down. Some cheap tricks. Okay. If you try and compare two graphs, we talked about if a, here's another cheap trick. What if a was 1 versus a was 2? Remember, these are x square graphs. So for x square graphs, we have a pattern. The pattern for all x square graphs is this. Let me draw the pattern here. X squared is, what's 0 squared? 0 squared is 1. 1 squared is 1. So 1 step over, square that, 1 step up. What is 2 steps over? 2 steps over is 2 squared. 2 squared is 1, 2, 3, 4. If I go in the negative direction, negative 1 squared is positive 1, 1 step up. Negative 2 steps over is positive 1, 2, 3, 4. We can draw a parabola by just counting our steps. And that's actually always based on the a value. So what if it was 1? Well, 1 step over, 1 step up, 1 step over to the left, 1 step up. That's a parabola when a is 1. But I'm not sure if you guys realized this already. What if a was 2? It doubles your speed of your graph. So instead of going 1 step over, 1 step up, we take times 2. We take 2 steps up. 1 step over should be 1 step up. 1 times 2 is 2. What if I take 2 steps over? 2 squared is 4 normally, right? But since we're timing 2, we're twice as fast, we're going to be up here at 8. And nobody wants to graph that. What if the a value was negative? We do the same exact thing, actually. So we take 1 step over, we normally would go 1 step up, right? But what is 1 times our coefficient negative 1? What's 1 times negative 1? It's negative 1. So we actually go 1 step down. 2 steps over should be 1, 2, 3, 4. It should be 4. But what's 4 times negative 1? Negative 4. 1, 2, 3, 4. So that a value really messes me up, but also it gives me a hint of which way I should be going. So let's go ahead and look at IXL. I'm sorry, I'm kind of pushing it today. Come on, IXL. I'm going to jump to it. I want to show you how fast this last one's going to be, okay? K dot 13. Yeah, 13, and we're looking at algebra 2. You guys are just going to match the quadratic to the function. All right. So using the basic skills I just taught you, that's it. Just the basic skills I talked about. Looking at that front coefficient, that front a value. Which graph here would be positive? Okay, looking here, I see x squared, 1x squared versus negative 2x squared. We said if the a value is positive, we're going up. And if the a value is going down, we're going down. Now here is a trick. I want you guys to look here, please. Everyone see that's negative 2? Negative 2, right? A is negative 2. I want you guys to count. From the vertex, sorry, you guys can see my, from the vertex, if I take one step over, we went 2 steps down. One step over, 2 steps down. Bam, that's what this means. That's how you spot it. Submit. I know it's right. Look at this next one. Obviously one's positive, obvious one's negative. That a value helps us automatically figure out which graph is which. Positive means going up, negative means going down. No work. No work. But just to make you believe, a value on the right side is positive 1. So isn't from the vertex 1 step over, 1 step up? No, that kind of worked out. 2 steps over, 1, 2, 3, 4. Yeah. On our left, same exact idea, except it's a negative 1. 1 step over, 1 step down. 2 steps over, negative 1, 2, 3, 4, because we multiply our parent graph by negative 1. Submit. Now, this one looks a little different, but it's not. The same thing. Except, look, both graphs are negatives. Oh no, both graphs are negative. But which one is more negative? So look at the a value. On my left here, we have negative 1, and we have negative 2. So I want you to examine the graphs. For this graph here, from the vertex, 1 step over was 2 steps down. Ah, that's has a multiplier on it. Over here on the right, 1 step over, 1 step down. Ah. So we can automatically say this without doing any work at all. We are being critical here. We're looking at the characteristics of the graph. All right. We have x and then 1x squared and 2x squared. So we know the 2 is going to be faster, right? 2 is going to be faster. The skinnier. If you want to zoom in, 1 step over, 2 steps up. From the vertex, 1 step over, 2 steps up. Yep.
Mr. Ko,
Yes.
doesn't it not equal something like the 2 equation? Can you go up? It says equal to 2x, 2 times the x plus 8. So should it be different?
So match each quadratic function. So what happens is I'm just taking this. So what they did is they wrote it in vertex form. They completed the square. So looking at 2 parentheses x plus 8 squared, what's the vertex of that problem? The vertex is negative 8, 0. Negative 8, 0. Okay, so they actually completed the square on that problem. These problems here, they're saying, hey, look, they look exactly the same. And then they factored it for you. Now we have to use more information because they look very similar. Now using our vertex form, x minus 1, the vertex is positive 1, 0. Positive 1, 0. On the left, it's negative 1, 0 in vertex form. So I have to use a couple more of our tricks since these are both very similar. This one here, we can look at the coefficient. If you want to double check, we have our zero product property acting out here. So the zero product property says, hey, what would make this go to 0? X would be 0 and negative 2. X would be negative 2 and positive 2. These are the zeros of the graph. So the first graph, this guy, the zeros are, again, 0 and -2. That graph is right here. See that 0 and -2? The second graph, using our zero product property, is going to be -2 and 2. -2 and 2. But since this was only two options, and one coefficient was -2 and one was -1, we could just look at that. So there's a lot of different entry points to this, which is kind of cool. So we're kind of using everything that we learned in the last couple weeks. So we said it was going to be 2 and it's going to be 1. All right, so you guys are going to play with that. This one, they're both x squared. So which one is it? Darn it. Well, if you factored it, and they did factor it for you here, we know we have a 0, a vertex, at +5, 0. Or you can look at the roots at +5. So know for sure that one's over here. And the next one is an x squared graph plus 2 spaces. X squared moved up 2 spaces. Right? X squared moved up 2 spaces. That's another way of looking at this. We mentioned before, right when we first started this, we can move the graph up and down. Okay. So you guys are going to practice that as we close up this section using roots, as well as looking at determinants and looking at coefficients to help you graph.